Imagine spending hundreds of billions of dollars building the world's most powerful AI, only to discover that the biggest problem was never the AI chips themselves, it was how those chips talked to each other. Now, China says it has a solution. And strangely enough, that solution isn't a faster processor, it isn't a more powerful GPU, it's glass. Yes, glass. For decades, copper has been the invisible backbone of modern computing. Almost every AI server, every data center, every supercomputer has depended on it. But now China is replacing copper with glass for AI. And if this technology delivers what researchers claim, it could completely change how the next generation of AI is built. So why would anyone replace one of the world's most important materials with something as fragile as glass? What problem did copper suddenly fail to solve? And is this the beginning of a completely new AI race? Because once you understand what's really happening here, you'll realize this story was never about copper or glass, it's about the hidden weakness that could decide the future of artificial intelligence. For years, the entire world believed the AI race came down to one thing: building faster and more powerful chips. Every headline was about NVIDIA, AMD, Huawei, and whoever could design the next breakthrough processor. Governments invested billions, companies fought over advanced semiconductors, and every new AI model seemed to need even more computing power than the last. It all made one message seem obvious: the company with the fastest chips would win the AI race. But behind the scenes, engineers were running into a problem that no new GPU could solve. Imagine building a Formula One car, then forcing it to drive through city traffic. It doesn't matter how powerful the engine is, if the road is blocked, the car can never reach its full speed. That's exactly what's happening inside modern AI data centers. Today, the world's largest AI models don't run on one chip, they run on thousands of GPUs working together at the same time. And those GPUs have to exchange an unbelievable amount of data every second without slowing down. That's where everything starts to fall apart. Because the real bottleneck isn't creating intelligence anymore, it's moving intelligence. And that's the problem China believes it has finally found a way to solve. To understand why this matters, you first need to understand how modern AI actually works. When you ask an AI a simple question, it might feel like a single computer is generating the answer. In reality, that's almost never the case. Today's most advanced AI models are spread across thousands of GPUs, all working together like one giant brain. Every calculation, every prediction, and every response depends on those GPUs constantly exchanging information with each other. Not once every minute, not once every second, millions of times every second. And here's where the real problem begins. The larger the AI model becomes, the more data those chips need to exchange. Eventually, the GPU spends so much time waiting for data, they can't even use their full computing power. Think of it like the world's smartest team trying to solve a problem together, but only one person can speak at a time. No matter how intelligent the team is, progress slows down because communication becomes the bottleneck. The same thing is happening inside AI data centers. The processors are getting faster every year, but moving data between them isn't keeping up at the same pace. And that's exactly why some engineers believe the future of AI won't be decided by who builds the fastest chips. It will be decided by who finds the fastest way to move information between them. And that's where copper suddenly became the biggest obstacle. For decades, copper has been one of the greatest materials in modern technology. It's reliable, relatively inexpensive, and incredibly good at carrying electrical signals. That's why almost every computer, server, and data center on Earth has depended on it. So if copper has worked so well for so long, why replace it now? The answer is surprisingly simple. Because AI is growing much faster than copper can keep up. As AI data centers become larger, the distance between thousands of GPUs also increases. Every time electrical signals travel through copper, they lose energy, they generate heat, they require more power. And as the speed increases, those problems become even harder to control. Now imagine tens of thousands of GPUs trying to communicate at exactly the same time. Even a tiny delay, repeated billions of times, can slow down an entire AI system. Engineers call this a bottleneck, and every new generation of AI makes that bottleneck even worse. This is why simply building faster GPUs is no longer enough. Because no matter how powerful the processors become, they still have to wait for information to arrive. That's when researchers started asking a completely different question. Instead of making electricity move faster, what if they stopped relying on electricity altogether? That single question led engineers towards something that could completely change the future of AI: light. Using light to move information isn't a new idea. The internet itself has relied on optical fiber for decades. But bringing that same technology inside AI data centers is a completely different challenge. Inside a modern AI cluster, information has to travel between thousands of processors with incredible speed and almost perfect precision. That's exactly where China believes it has found an advantage. Instead of pushing electrical signals through copper, Chinese researchers are developing systems that send data as pulses of light through optical connections. Light travels faster, generates far less heat, and carries enormous amounts of information with much lower energy loss. That means AI servers can spend less time waiting for data and more time actually processing it. But here's the interesting part. China isn't just replacing cables, it's redesigning how AI systems communicate from the ground up. Universities, research labs, and technology companies across China are investing heavily in optical interconnects and silicon photonics, technologies that many experts believe could define the next generation of AI infrastructure. And then, one research team made a claim that caught the world's attention. They said their new optical system could dramatically reduce the biggest bottleneck in modern AI. If that claim is true, this isn't just another engineering upgrade. It could be the beginning of a completely different way of building artificial intelligence. One of the biggest moments in this story came from a research team at Peking University. Instead of trying to build another faster AI chip, they focused on something almost everyone else was overlooking: communication. The team developed an all-optical interconnect system designed to move information between AI processors using light instead of traditional electrical connections. According to the researchers, the results were remarkable. Their prototype was able to complete certain AI inference tasks up to 100 times faster while using only a fraction of the computing resources required by conventional approaches. If those numbers hold up in real-world deployments, the implications could be enormous. Because improving AI isn't always about building a more powerful processor. Sometimes it's about making sure every processor spends less time waiting. Think about it this way. Imagine a factory with thousands of workers. If materials arrive late, it doesn't matter how skilled the workers are, production slows down. But if every worker receives exactly what they need the moment they need it, the entire factory becomes dramatically more efficient. That's exactly what this technology is trying to achieve. It's not making the workers smarter, it's making communication almost effortless. And suddenly, something as ordinary as the cable connecting two processors becomes one of the most valuable technologies in the AI race. But here's the twist. China isn't the only country chasing this future. In fact, some of the biggest names in the global AI industry are racing toward the very same destination. At first, this might sound like a story about one Chinese research project. But the deeper you look, the bigger this story becomes. Because China isn't the only one trying to replace electrical connections with light. Across the world, some of the biggest technology companies are investing billions of dollars into the exact same idea. NVIDIA is pushing optical networking for next-generation AI clusters. Intel has spent years developing silicon photonics for high-speed data communication. TSMC is working with industry partners to bring optical technologies even closer to future AI chips. And startups backed by some of the world's largest investors are racing to solve the same bottleneck before anyone else. That tells us something important. This isn't an experiment anymore. It's an industry-wide shift. For years, companies competed to build faster processors. Now they're competing to move data faster than ever before. And whoever solves that problem first could unlock AI systems that are not only faster, but also cheaper, more energy efficient, and dramatically easier to scale. That's why this race matters so much. It isn't just about building the world's smartest AI. It's about building the infrastructure that every future AI model will depend on. But even if the technology works exactly as promised, China still faces one major challenge before this vision can become reality. So why is China in such a strong position? The answer goes far beyond a single breakthrough. Over the past decade, China has quietly built one of the world's largest technology manufacturing ecosystems. From optical components and fiber networks to advanced packaging and AI hardware, much of the supply chain already exists inside the country. That means new technologies can move from the laboratory to large-scale production much faster than many people expect, and timing couldn't be more important. China is building massive AI data centers, training increasingly powerful AI models, and expanding its digital infrastructure at an incredible pace. The demand for faster communication between AI chips is growing every single day. That creates the perfect environment to test new optical technologies in real-world systems. But having an advantage doesn't guarantee victory. History is full of technologies that looked revolutionary in the lab, yet struggled when it came to mass production. Can these optical systems be manufactured at scale? Can they remain reliable inside thousands of AI servers running around the clock? And perhaps the biggest question of all, can they do it at a cost the industry is willing to pay? Because if the answer to any of those questions is no, copper isn't going anywhere. At least, not yet. As exciting as this technology sounds, replacing copper won't happen overnight. In fact, the biggest challenge isn't proving that light is faster. Everyone already knows it is. The real challenge is turning an impressive laboratory breakthrough into something that can power millions of AI systems around the world. Building optical interconnects is far more complex than manufacturing traditional copper connections. The components have to be incredibly precise. Even the smallest manufacturing error can affect performance. Then there's the cost. Right now, advanced optical technologies are still more expensive than conventional electrical connections in many situations. For companies operating thousands of AI servers, even a small increase in cost can quickly become a multi-billion-dollar decision. There's also the challenge of compatibility. Modern AI data centers weren't designed to abandon copper overnight. For years to come, many systems will likely use both technologies together, combining electrical and optical connections where each one makes the most sense. So no, copper isn't disappearing tomorrow. But that's not the point. The point is that the direction of the industry is changing, and once the world's biggest technology companies begin investing billions in the same solution, history shows there's usually no turning back. The question is no longer whether optical communication has a future. The real question is who will lead that future. Now imagine an AI data center 10 years from today. Instead of thousands of processors struggling to exchange information through electrical signals, vast networks of AI chips communicate using pulses of light, moving enormous amounts of data almost instantly. Training models that once took months could take weeks. AI systems could respond faster, consume less energy, and scale to sizes that seem almost impossible today. That doesn't just mean better chatbots. It could accelerate medical research, scientific discoveries, autonomous vehicles, robotics, and technologies that haven't even been invented yet. And that's why this story matters. Because every major leap in computing history has been driven by one simple idea. Remove the bottleneck and everything else moves forward. First, it was faster processors, then larger memory, then more powerful GPUs. Now, the next bottleneck appears to be communication. And if communication changes, everything built on top of it changes too. This is why governments, universities, and the world's biggest technology companies are investing so heavily in optical communication. They're not chasing a faster cable. They're chasing the next generation of artificial intelligence. And right now, China has positioned itself as one of the countries trying to lead that transformation. But whether it ultimately wins or not, one thing is already becoming clear. The AI race is no longer just about building smarter machines. It's about building a smarter way for those machines to communicate. So, did China really replace copper with glass for AI? Not entirely. And that's exactly what makes this story so fascinating. The real breakthrough isn't about eliminating copper overnight. It's about recognizing that the future of artificial intelligence may depend less on building faster chips and more on helping those chips communicate at the speed of light. Whether China's approach becomes the new global standard is still an open question. Researchers still have to prove these technologies at massive scale. Companies still have to reduce costs, and the rest of the world isn't standing still. The United States, Europe, and other technology leaders are all investing in the same race. But history has shown something again and again. The biggest technological revolutions rarely begin with a product. They begin with a problem that nobody else noticed. Years ago, the challenge was creating powerful processors. Today, the challenge is making those processors work together without wasting time, energy, or performance. And if light truly becomes the new language of AI, we may one day look back at copper the same way we look back at dial-up internet. Not because it was bad, but because the world simply found something better. The next revolution in artificial intelligence may not arrive inside a new chip. It may already be traveling between those chips at the speed of light. The next time you hear someone say the future of AI depends on building a more powerful chip, you'll know that's only part of the story. Because in the race to create the world's smartest machines, intelligence alone isn't enough. Communication may be just as important. And right now, one of the biggest battles in artificial intelligence isn't happening inside the chips. It's happening between them. Whether China ultimately leads this revolution or not, one thing is certain. The future of AI will belong to whoever can move information faster, farther, and more efficiently than everyone else. And that race has already begun. Stay curious. We'll see you in the next Byte Dynasty.